Hi guys, welcome to your lesson on 12.2 on analyzing arithmetic sequence. In lesson 12.1 we talked about sequences in series just generally, and in section 12.2 now we're going to be talking about an arithmetic sequence. Alright? Now an arithmetic sequence is a sequence in which the difference between consecutive terms is constant. Alright, that consecutive difference, we call that the common difference, and we use the letter D to denote that common difference. Alright, so another way to say this is we either add or subtract some number to get the next term. Okay? So pretty straightforward. Again, we're going to add a number or subtract a number to get the next term in the sequence. All right? An arithmetic series, just like we talked about a series last section, a series results when you add up all the terms of a sequence. So an arithmetic series is an expression formed by adding the terms of an arithmetic sequence. We denote that sequence as sub n. All right? And so that's basically some of the definitions that you have for this lesson. Let's take a look at actually identifying arithmetic sequences. Now, this looks a little bit silly, but what we're going to do is we're going to do a2 minus a1, because I want to know what did I add or subtract from negative 5 to make it a negative 3. So I need to find the difference, negative 3 minus negative 5. I need to find the difference, negative 1 minus negative 3. I need to find 1 minus negative 1 and 3 minus 1. So that's 2. This is minus a minus, which is 2. That's a 2. And that's a 2. So you can see that my constant difference is 2. So we would say that D is equal to 2 because we're adding 2, adding 2, adding 2. Now if we go the other way around, we get negative 2. But that doesn't make sense because if I go from negative 5 to the next term, I don't subtract 2, I have to add 2. So it's really important that when you find the constant difference, you go from the second to the first, from the third to the second, and so on and so forth. Again, this is an arithmetic sequence. Go ahead and try the checkpoint problem. I'll have you guys try that one. We'll be right back with a solution. All right, so if I do 27 minus 32, I get negative 5. If I do 21 minus 27, I get negative 6. And right away, those two don't match, and so this is not an arithmetic sequence because we're not adding the same thing. And again, you could say, well, I'm not adding, I'm subtracting. But yeah, I'm adding negative 5, and then I add negative 6. And so since those aren't the same, this is not an arithmetic sequence. So the general rule for all arithmetic sequences follow this form. A sub n is equal to a sub 1 plus n minus 1 times d, where n represents the term number. All right? A sub 1 represents the first term in the series, or I'm sorry, in the sequence, and d represents that constant difference that we talked about before. All right, the common difference. And again, that has to be a constant. It can't change. Take note of this example here. All right, so top of the next page then, we want to write a rule for the sequence, and then we want to find the 19th term of the sequence. All right, so if I simply do 9 minus 2, I get 7 here. And 16 minus 9 is also 7. And 23 minus 16, rather, is also 7. So it looks like to go from one term to the next, I'm constantly adding 7 here. All right? So therefore, my constant difference, D, is 7. And so my rule is, again, here's the general rule. We're going to plug in all the stuff we know. A sub 1, the first term in the sequence, is 2. And then n minus 1 times D, and since my constant difference is 7, we're going to put a 7 here. Go ahead and distribute that 7. You get 2 plus 7n minus 7. And then when I combine like terms, I get 2 take away 7. And so your answer is negative 5 plus 7n. All right? So if I want to find the 19th term, I simply go negative 5 plus 7 times the 19th term, which would be n is equal to 19. Okay? And I end up getting right here that this is 128. So let's try another. It says the sequence is arithmetic. Okay, the next one is this an arithmetic sequence? Well, we got to go 45 take away 57. Okay, and 45 take away 57. 45 take away 57 ends up being negative 12. Let's see if that works again. Do I subtract 12 to get from 45 to 33? Well, you can check that later on your own, but we do in fact continually subtract 12 or actually add negative 12. So my constant difference here is negative 12. Okay, my first term in the sequence is right here, it's 57. All right, so then I'm going to simplify. I'm going to distribute the negative 12. Okay, when I do negative 12 times n, I get negative 12n. When I do negative 12 times negative 1, I get positive 12. And out in front of this thing, I still have this 57. Okay, so 57 plus 12 becomes 69, take away 12n, and so that's my sequence. All right, that's the rule for my sequence. So when I want to find the 19th term then, okay, my 19th term then becomes 69 minus 12 times 19, and I'm simply plugging in that 19 there. This is negative 159. Okay, you guys try a couple of examples here. You try the 2 checkpoints. We'll be right back with solutions. All right, the first thing we need to do is we need to figure out our constant difference. So 5 minus 9 becomes negative 4, and that makes sense because to go from 9 to 5, I have to take 4 away. To go from 5 to 1, I have to take 4 away. So my constant difference is negative 4. So the general rule then says a sub n is equal to a sub 1 plus n minus 1 times my constant difference, which in this case is negative 4. Okay? So now I'm going to go back and take out a sub 1, and I'm actually going to put in what the first term is in the sequence. It happens to be 9. Distributing the negative 4, this becomes 9 minus 4n plus 4. And then combining like terms, 9 plus 4 becomes 13 minus 4n. Okay? If I want to find the 22nd term in that sequence, I do 13 minus 4 times 22. 4 times 22 is 88, and then 13 take away 88 becomes negative 75. All right, let's try the next one. In the next one, my numbers are getting bigger, so it looks like we're adding something. The question is what? Well, what's negative 9 minus negative 15? Remember, minusing a minus turns into plus, and so my constant difference, or my common difference in this case, is 6. All right, so the general rule then says a sub n equals a sub 1 plus n minus 1. Multiply that by your constant difference, which in this case is, or common difference rather, which is 6. Okay, once again, I'm going to go ahead and replace a sub 1 with the first term from the sequence, which is negative 15. All right, distribute. This is 6n minus 6. Still have the 15 out in front, the negative 15. So negative 15 plus, or I'm sorry, minus 6 becomes negative 21 plus 6n. So the rule for a sub n is simply negative 21 plus 6n. So now if I want the 22nd term of that sequence, I simply do negative 21 plus 6 times 22, and this ends up being positive 111. All right, so that'd be the 22nd term in that sequence. All right, so go ahead and flip over to the next page. Let's take a look at another example here. What happens if we give you the common difference and we give you one of the terms in the sequence? We don't give you the first term. Well, basically then we would just make up an algebra problem. Okay, the general rule says that a sub n is equal to a sub 1 plus n minus 1 times d. In this case, we don't know what a sub 1 is, but we do know that a sub 11 is equal to 41. And so n equals 41. I'm sorry, a equals 11. So we have 41 equals a sub 1 times 11 minus 1. Whoops, I don't have to put that in there. It's already in there. 11 minus 1 times my constant difference, or my common difference, which in this case is 5. Now, we don't have to distribute this. We can simply do 11 minus 1, which is 10. And 10 times 5 becomes 50. And so now we're just going to minus 50 from both sides. Okay, negative 50 and 41 becomes negative 9. Okay, so a sub 1 becomes negative 9. Negative 9 is my first term in the sequence, so I put a negative 9 there. Again, my common difference is 5. Go ahead and distribute. This is negative 9 plus 5n minus 5. Combining like terms, we get negative 14 plus 5n. All right? Now, the next part of this asks you to create a table. A couple different ways you can create the table. You can certainly take this function that we just had, 14 minus 5n, and you can plug that into y1 on your calculator and use an x instead and use the table feature there. But now that we know the first term in the sequence is negative 9, we know that my common difference is simply to add, or I'm sorry, to add 5. So it's supposed to be plus 5n, sorry. All right, and so we know that this is plus 5, so that's negative 4. We know we're going to plus 5, so that's 1, 6, 11, and 16. And so to graph those points, we would go to 1, negative 9. These are counting by 3, so there's 1, negative 9. 2, negative 4 is in that neighborhood. 3, positive 1 is in that neighborhood. 4, 6 is in that neighborhood. And 5, 11 is roughly there, maybe a little higher. And 6, 16 is somewhere in here. Now, what do you notice about these points? Well, they look like they're somewhat linear. And they should, because realistically, this is a line with a slope of 5 and a y-intercept of negative 14. All right? Okay, next piece then. What happens if they give you two terms and they don't give you the common difference? Well, now there are two things we don't know. We don't know A1 and we don't know D. We don't know A1 and we don't know D. So I have two equations with two unknowns. Well, this sounds like systems of equations, doesn't it? A sub 22 is 87, and so this is 87 is equal to A sub 1, which we don't know, and then 22, because we're talking about the 22nd term, 22 minus 1 becomes 21D. In the second one, A sub 6 is equal to 7. Okay, this is a 7 here. And then A sub 1, 6 minus 1 is 5. And now to solve that system of equations, we just simply subtract the whole second equation. This becomes 80. These cancel out. I get 16. Dividing both sides by 16, you get D is equal to 5. All right? So now I know that my constant difference, or my common difference, is 5. And then I just plug in those numbers from the rule. Okay, I'm going to use this one here. Okay, 87 is equal to A sub 1. Okay, and then A sub 1, we don't know yet. This is 22 take away 1 times 5. Well, this ends up being 21. All right. So when you do 22 times 5, or 21 times 5, you get 105 here. We subtract that from both sides, and I get A sub 1 is equal to negative 18. Now I plug in all the stuff I know. This is negative 18. N minus 1 times the constant difference of 5. Go ahead and distribute. You get 5n minus 5. And I still have the negative 18 out here. Those two together go to negative 23 plus 5n. All right? All right. 2 checkpoints at the top of the next page. Why don't you guys go ahead and try those 2 checkpoints, and we'll be right back with solutions. All right. In this example, we have A sub n is equal to A sub 1 plus n minus 1 times my d. And we know some things. We know that we want the 15th term, which is 107. We don't know the first term. But again, this was the 15th term, so this becomes 15 take away 1, or 14 times d. All right? Now from there, we know our constant difference, and our constant difference is given. That's right here is 12. So this is 12. All right? Okay, so 14 times 12 is 168, so we're going to minus 168 from both sides. And I get A sub 1 is equal to negative 61. All right, and so my rule then becomes A sub n equals negative 61 plus n minus 1 times my constant difference, which is 12. Go ahead and distribute. Negative 61 plus 12n minus 12. These will turn into negative 73 plus 12n. All right. Now, if I want A sub 22, I simply do negative 73 plus 12 times 22, and that tells me that that A sub 22 ends up being positive 191. All right. In the second one, we have to set up a system of equations. So A sub 20 is equal to A sub 1 plus n minus 1 times my constant difference of d. And then A sub 5 is equal to A sub 1 plus n minus 1 times my constant difference of d. Now, we can change some things around in here because we know that this is now the 20th term, so this becomes 20 take away 1. And we also know that this is the 5th term, and so this becomes 5 take away 1. So this is 19, and this is 4. Let's rewrite our equations. Now let's plug in what A sub 20 is. A sub 20 is 1, and that equals A sub 1 plus 19d. In the second one, we know A sub 5. We know A sub 5 is 91, so 91 equals A sub 1 plus 4d. Okay? Now, when I go minus, 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 these cancel out, and I get negative 90 is equal to positive 15d. And so if I divide both sides by 15, I get d equals negative 6. Okay? Now I know my common difference is negative 6, and let's see if we can't finish this up down here below. Okay, you have A sub n is equal to A sub 1, which we still don't know, n minus 1 times d, which is negative 6. Okay, now we have a term that we can use here. Let's go ahead and use, instead of using A sub n, okay, let's go ahead and use A sub 5 here. So as you know, A sub 5 is given as 91, all right? And since this is now 5, this is going to be a 4. Okay, so 4 times negative 6 is negative 24. So add 24 to both sides. You get a sub 1 is equal to 115. All right? And so that becomes the first term in my sequence. Again, plugging that all in becomes a sub n equals 115 plus n minus 1 times negative 6. Distribute negative 6n plus 6, and then add that to the 115, and so I get a sub n, let's put it back over here, a sub n is equal to 115 take away 6, I'm sorry, adding 6, this is a plus here, all right, so that becomes 121 minus 6n, and I'll let you guys go ahead and say for a22, you can plug in 121 minus 6 times 22, okay, that comes out to be negative 11. So now that we've taken a look at those checkpoint problems, let's look at the sum of a finite arithmetic sequence. Or I'm sorry, a finite arithmetic series. When you're talking about a series, what you're talking about is we're talking about adding up the terms of an arithmetic sequence. And so basically what we have then is it says the sum of the terms of a sequence up to the nth term becomes n times a1 plus a sub n all over 2. Now, we look at this here and it says it's the sum of these two divided by 2. Well, isn't that the same thing as the mean or the average of those two terms? All right. So it's the average of the first and the last, or nth term, whatever the last term is a sequence based on what letter or what number of n I've chosen, what term number. So it's the average of the first and last terms. All right. And then we want to multiply that by the number of terms, which in our case is n. All right, so let's see if we can do one of those. Let's go ahead and try this example number 5. We want to find the sum of the terms of the first 15 terms of the series 9 plus 3i. Okay, so again, I is my index. This becomes 9 plus 3 times 1. And so the first term in this sequence will be 9 plus 3, which is 12. And then I want 9 plus 3 times 15, which is 45. 9 and 45 ends up being 54. And so now we want to take the number of terms we want, 15, multiply that by the average of the first and last terms. And again, to take the average, we add them, divide by 2. And you guys can do the math on that, but that's 495. And so there are 495 would be the sum of that series from 1 to 15 of that pattern, 9 plus 3i. Okay? All right, so why don't you guys try the checkpoint problem at the bottom of the page. We'll get you back with a solution in just a second. All right, so the first term then becomes 77 minus 4 times 1, which is 77 minus 4, or 73. The 18th term becomes 77 minus 4 times 18, and 77 times 4 minus 18 comes out to, or I'm sorry, 4 times 18 comes out to just plain old 5. And so if I want the sum of the first 18 series, S sub 18 will be 18 times 73 plus 5 all over 2. Well, this becomes 78 over 2. Multiply that by 18, we get 702 is the sum of those first 18 terms. So that concludes your lesson on 12.2 on arithmetic series and sequences.